In the last video, we took a look at the idea of how we might begin to represent continuous distributions pictorially. We said we wouldn't use a table like we did back in chapter 4, but we would begin to use a nice curve to help model this. And now in this section, we're going to take a look at how we can actually describe a uniform distribution. If you take a look at the box down here, I say that a uniform distribution is a continuous distribution where each value of the random variable x has the same probability of occurring. If I think about what that means, that would mean that each bar in the picture up here that I would have drawn would have all had the same height because they have the same probability. And I could think about what that would mean my curve would look like. I would end up actually with a curve that would be perfectly flat, like a straight horizontal line just above this horizontal line. It'd be perfectly flat. Remember, we said in the last video that each one of our different distributions is going to have an associated shape with it, and the uniform is actually one of the easiest. We'll see in a moment how we can easily do probability calculations using this formula. We can calculate the probability of a value of x occurring between two numbers. And we also have formulas here for how to calculate the mean and the standard deviation of our distribution. Now, in the same way as the last sections worked, we're going to be able to use our formula sheet here to help kind of guide us through each individual problem. We're going to have this nice flow chart for how to proceed through every question. Again, we're going to start by identifying what our random variable is and what it stands for. Try to identify which distribution we think it has. These are the options that we'll talk about here in chapter 5 and 6. Some checks to make sure that we're in the right column. Then the parameters. In this case, in uniform, we'll only write the mean and the standard deviation when we're specifically asked for it. And then we have a probability calculation down here. Okay, so let's see how this works in example number 1. Suppose the amount of time it takes to assemble a plastic module ranges from 27 to 39 seconds, and that the assembly times are, this is nice, uniformly distributed. Okay, so this is just like what we saw in the opening motivation in the last video. Now we're just told, let's assume that each individual time is just as likely as all the other times. They are uniformly distributed. You want to determine the likelihood of producing a module in a given time frame. So notice I'm going to start here right at the top of the formula sheet with, can I define what my random variable is? Well, my last sentence here really helps me out already. I can see that I could write something like this. How about we let x represent the amount of time it takes to produce a module. That's what we have, right? X is this random variable of the time. I don't know how long it's going to take. But I do know right away, again, following the formula sheet, that x has a uniform distribution. I'm just going to write that out because it's the next thing that I would always want to check. And of course, I know that that's true because the problem tells me that it's uniformly distributed. Okay. Well, now I could go down here and I could say, all right, the moment that I know I have a uniform distribution, I'm definitely going to want to sketch a picture of what that uniform distribution looks like. Well, this should actually be super easy to do. Remember that I'm going to be able to create a nice little number line down here. This is going to be for my values of x. And I know that I have values of x that go as low as 27, and they go up to 39. Now the shape above this, remember if it's uniformly distributed, is actually just going to be a nice straight line. Every single bar along the way would have been the exact same height. And so I'm going to get a picture that looks just like this. That's the picture of the uniform distribution in this case. Now, a couple things that I might want to know is maybe some things about like, where exactly is the average in this picture? I can maybe see where it would be located, but I don't know its value. Notice then that I can go ahead and use these formulas to find things like a mean and a standard deviation for this variable. What is the average length of time it takes to produce a module? And then find and describe the standard deviation. Well, I'm going to use the formula that I have up above. Notice to find the average, I can simply take A and B, which actually represent here my left side and my right side. So I'm going to call A 27 and B is 39. That's what I always do with these two values I call the left one A and the right one B. And that's how I know what to plug into these formulas. Notice here then that if I'm really just taking these two values, adding them up and dividing by 2, I'm finding their average. I'm finding like the number in between them. And that's how I find the average of this distribution. So notice I can just say my average for x is going to be 27 plus 39 over 2. That's the same as 66. 66 over 2. And so that's a total of 33. And I'll put down the units on there, 33 seconds. So there's my average. I can also calculate my standard deviation by using the formula in the box above. Of course, remember that's also written on the formula sheet. This one's a little bit messier. It's b minus a, and then divided by, very strangely, a square root of 12. Okay, so let's see. I'm going to do my value of b minus my value of a, and over a square root of 12. If I simplify this down as much as possible, this is really just 12 over root 12. You could just plug this into your calculator right away. If you love simplifying a little bit more, you can actually rewrite this as just square root of 12 by rationalizing the denominator. And if you were to plug this into your calculator, you would see that you get roughly 3.4641. And of course, the units on there is still seconds. So of course we know what this means. It's pretty typical for us to get a module produced in 33 seconds, but don't be too surprised if it takes an extra or it's faster by about 3.4641 seconds. That happens all the time. Not very uncommon. So once I have all of these values down, it's actually then going to be really, really easy to compute some probabilities. And to compute probabilities, we'll take a look at some questions like Part D and onward. But we'll actually do that in the next video.